working with radicals, and actually there's at least one thing in here that maybe should have been part of part 1. But this is the way it's separated. I'll finish the whole deal here today. So working with radicals part 2, operations on square roots. First, adding and subtracting radicals. This isn't too bad. It looks intimidating, but when you see me do it, you'll be like, oh, that's not so bad. As long as you did a little bit of last night's homework, a little bit, where you know how to handle certain radicals. Okay, combining like radicals is similar to combining like terms. We're just going to be combining some like terms, and when you first look at this, first one, it's 5 root 3 plus 7 root 3 minus 2 root 3. Those are all root 3s, and anytime something is the same stuff, you can put it together. You got 5 apples plus 7 apples minus 2 apples. That's 10 apples when it's all done. So it doesn't matter what you're talking about if it's all the same. So radicals work the same way. Whatever root 3 is, I've got 5 of them, and then I'm going to add 7 of them. That's 12 of the root 3s. And I don't even know exactly what root 3 is. It's about 1.7, 1.732, something like that. But that doesn't matter for the sake of this question, is I know if you give me 5 of them and 7 more, now I got 12 of them. And if I have 12 root 3s, whatever root 3 is, and I take away 2 of the root 3s, I get 10 root 3s. Can we agree that's a lot simpler than what I started with? Okay? So you can do that with radicals. We didn't really run into that yesterday. You can add and subtract radicals as long as it's the same radical. It's got to be the same root part. These were all root 3s for the first question of the day. I did them with all root 3s. But B, they're not all the same. When you look at this, you're like, well, there's nothing I can do, because none of these are the same radicals. Mr. Todd you say, got to be same radicals. None of these are the same. But then someone who did their homework yesterday looks at these radicals and goes, I can adjust these. I can simplify them. Root 12, that must have come up. 12 must have come up yesterday. What 2 things multiply to 12 where one of them is a perfect square? And by perfect square, I mean something I can take the root of. 3 and 4. Now, me personally, I always go with the one I can root first. I take the perfect square first. So he said 3 and 4, but I'm going to write root 4, root 3. You might have 2, but after you've decided what the 2 numbers are, put the perfect square first. I think it's going to work out a little bit better that way. Then root 18. Root 18. What 2 things multiply to root 18, or multiply to 18, but one of them is a perfect square, and if that perfect square term scares you, I'm just saying, what something I can take the square root of? Root 9, root 2. Last night's homework's going to pay off. You did a bunch of this stuff, and you're like, oh, I'm pretty good at these now. I can reduce these radicals, not bad. Then tonight's homework's going to fly along, because we're just adding. This part of the lesson, I'm just adding these things when it's over. Then 27. What 2 things multiply to 27, but one of them is a perfect square? Root 9, root 3. And then 8. 8, we use 8 all the time. We love 8 as 1 because most people can do 4 times 2 in their head, and 4 is a perfect square. Again, your list of suspects are, here they are. I'll write them up here again. What am I looking for? I'm looking for, no, not 1. 1 doesn't help at all. I'm looking for whatever 2 squared is. That's 4. I'm looking for whatever 3 squared is. That's 9. I mean, and when you write your test, maybe across the top, you write this right off the top, like, you know, these mental math. Still, I'm a little slow on it, but this is what you're looking for. 4 squared equals 16. 5 squared equals 25. You just list those across the top. Those are the suspects. Those are the things I'm looking for that I could square root. So then on the next line, maybe some of you are skipping that line. You're able to do it in your head, maybe. But I skip and I go 2 root 3 plus 3 root 2 minus 3 root 3 plus 2 root 2. I felt my attention span waver there, so I better check that. Yeah, it's good. But that is not all. Oh, that is not all. As he fanned with the fan while bouncing on the ball. What now from today's lesson? Do you see it? Clearly rigged up the question, didn't I? I clearly rigged it up to exactly prove what I was trying to do.
Hello, Mr. Todd?
Hello?
Is Dora Lauren in class?
No.
No?
No, she's not.
Okay, thank you.
I could do the root 3's first. I'm noticing, though, I'll get a negative up front. Totally allowed. Totally allowed. I could write negative root 3 there. But sometimes we like the first term to be positive. I don't know why. But it doesn't matter. Okay, so I'll do it. But if we did the root 2's first, then you get a positive number first, which is nice. But anyways, root 3's. Negative root 3, if I combine those two, I'm going to underline those, just in case this gets out of hand at some point, and a lot of terms. And then 3 root 2 and 2 root 2 is 5 root 2. Your calculator can handle this. You could just type this in. It would give this. I'll give you 0 marks and bring you along to 11U to see what you could type into your calculator. But it is nice to reassure yourself that you've done all the steps right, because it gives you the final answer. Maybe it might give it in the other order, actually. It probably would do that. It would do the positive number first, usually, if you've got a good calculator. If you don't, well, maybe it's time to upgrade. Same as when you first year university, whoever your girlfriend, boyfriend is, time to upgrade, you know? Question?
So when it says like where, okay, so the 5 and the 2, like, I mean the 3 and the 2, you added them and then it's like 5, squared 2. But what happened to the other one?
2 root 3 minus 3 root 3 would be negative 1 root 3. And it wouldn't be wrong to write negative 1, but I didn't write the 1 there, that's all. Yeah, good.
How did you get negative root 3 though? Oh, is it just because the 3 and the
2 minus 3 is negative 1.
Yeah,
Yeah.
my bad.
It's good? Other questions there? More time? If you feel like you're scrambling to copy all the time, don't forget. Whenever I can, I put up a base version of the notes. You would have all this that you could print out beforehand. And you iPad people, you can get it right off the website, right, all ready to rock and roll. I would say in the AP Calculus, I don't want to exaggerate, it's at least 1 in 3 now of people that just do it all on the iPad. So there. Start thinking about that as a Christmas gift. They should go on sale soon too. And better yet, I don't know if on Tuesday, I don't know if the 11 came out, but if the 11 comes out, the 9 will go on for a good sale if you watch. And the difference between the 9 and the 11 for most people, it's not really all that much difference. We've got a 7 and an 8 at home that are working perfectly well. Like, we use them all the time. So you don't have to get hung up in getting the brand new one. When the brand new one comes out, it's a great time to grab the old one for a cheap price. Yeah. Yeah. Four root 3, 3 root 20, negative root 12, plus 6 root 45. Feel free to be annoyed, but the first move in these is to reduce all those radicals. I couldn't really make the point very well yesterday why we want to reduce radicals, but now you're finding out why you want to. The best chance of simplification we have is to reduce all those radicals. Now, 4 root 3 is as good as I can do it right now. Root 20, root 20, root 20. Which of those suspects divides into 20? 4 and 5, and he's done the perfect square first. Then 12. See how the numbers get repetitive. They use a lot of the same ones. Root 4, root 3. And 45. Was 45 literally in the previous page? No, it wasn't. But it just seems like they're repetitive. They usually use reasonably nice numbers. Not always. Let's see. Divides into 45. 9 and 5. How are they getting them so fast? If you're not a mental math person, here's the way to do it. You get one of those apps on your phone that just does multiplication tables. Yeah, and just tests you on it. But start off with low numbers. Start off with like up to 5 times 5. So you just, okay, I'm confident up to 5 times 5. Then a couple days later, put 6s in. And 7s. Don't be embarrassed by this. It just helps in all the math we're going to do. It's not going to go away. Having up to 9 times 9 will just make your homework go faster because you can handle those things. I've got 2 lines I'm going to do of fixing up here, because this is 4 root 3 plus 3 times 2 times root 5. And then this is 2 root 3. And this is 6 times 3 times root 5. So don't be afraid of an extra step here. Maybe you don't need that step. Maybe you can do all of that stuff in one line. And do you see it? Again, obviously this question has been rigged up to work out and prove the point that simplifying radicals makes it so you might get simpler radicals. Yes, I did that. But also a much simpler expression because I can combine like terms. What do I got? 4 root 3, subtract 2 root 3, and 6 root 5 plus 18 root 5 is 24 root 5. And I'll bring that back up on the screen. Don't panic if you haven't got that copy down. But I just want to punch it into the calculator just in case you're still hanging on like grim death to your old calculator, which you'll do in first year university too. You'll hang on like grim death to this high school sweetheart. And by about Thanksgiving, you'll be like, okay, that's it. Can't do this anymore. Mrs. Todd calls it dropsgiving because everybody breaks up with their high school boyfriend or girlfriend at Thanksgiving. It's supposed to be a calculator joke. Maybe you haven't broken up with your old calculator yet. Let me just show what your calculator can do to help you here. 4 root 3 plus 3 root 20 minus root 12 plus 6 root 45 equals 24 root 5 plus 2 root 3. It wrote it the other way around for whatever reason it decided to do that. How many marks do you get for writing this? None. But it helps you, it makes you feel good. You're like, okay, I got it. I didn't make any little mistakes along the way. Do you have questions about that example? Is it okay? Not bad. If you did yesterday's. If you're good with this simplifying the radicals, today I'm not showing you too much really. Okay? Combining operations. Multiplying a radical by a binomial using the distributive property. Oh, the description makes it look like it's really scary here. That description is the worst. Good for getting out of chores though. Get home tonight, mommy says, can you empty the dishwasher? Like, I'd like to. You know I want to empty the dishwasher. But I'm busy multiplying radicals by a binomial using the distributive property. And they're like, okay, you do that, I'll empty the dishwasher. Yeah. Expand and simplify. Oh, let's go back. There's a reason we taught these things in the order we did. Multiply on the outside, addition on the inside. When that happens, the distributive property applies. So it's 3 root 2 times 2 root 6 and 3 root 2 times root 10. So that's the only new thing in this example is I'm going to distribute within this. So what I get is 3 root 2 times 2 root 6 plus 3 root 2 times root 10. Do you have to write that step out? Maybe. Yeah, it's back to the cat in the hat thinking. To keep track of everything that's going on here, maybe you need this step to go, okay, I'm taking 3 root 2 and I'm multiplying it by 2 root 6, and then I'm taking 3 root 2 and multiplying it by root 10. Then we're back to last night's homework at that moment. And by that I mean, truly, if you didn't get to any of last night's homework, the proper move tonight or the weekend is to go, let's do radicals 1. Let's not try and jump into radicals 2. Let's go back and knock down radicals 1, or at least a bunch of it, till you're like, yep, I got this. Then radicals 2. But if you finish radicals 1, you saw there's some area questions there. And if those pop up on the test, you want to be ready for them. So don't do 1 and 2 and skip the rest of your homework. If you can't get your homework done, do 1, 2A, 2C, 3F, and get those last 2 questions, because those are the ones that are going to come up and bite you on a test.
Is it kind of just like how normal distribution is, where you do like 3 times 2 and then like 2 times?
Hold on. What I just did was normal distribution. This is not distribution because it's all multiply. Distribution is about multiplying by things that are added together. That's a big point. And if that's glossing by you a little bit and your brain's like, what? Yeah, I know. That's a big point in all this that gets lost in the shuffle. Distribution, these arrows I drew are for when there's addition in there. When it's all multiplication, life is much easier. You don't got to distribute. You just have to multiply this in the order you feel is the easiest way to handle it. Again, multiplication is commutative. My kids are loving this. They're addicted to this. If I ask them in the driveway as they're waiting for the bus, if I say 6 times 8, they're like, Daddy, that's the same as 8 times 6. I'm like I don't know. I'm like, yeah, I know. And they're wound up because they figured out that you only need to know half the times tables. You can multiply any way you want, and I choose to multiply this way. I didn't really change the second one at all. And the reason I chose to multiply that way is because I can multiply 3 and 2 together. I can simplify that situation. Do we need this line? No, it could be once you're getting good at these that you go right from, actually some of you, you might jump from here all the way to this next step once you get rolling. You might. 6, not 3. 6 root 12 plus 3 root 20. I can multiply the coefficients together and I can multiply the radicals together. I can multiply the stuff that's regular numbers together and then I can multiply radicals together. That's what we found out yesterday. When you multiply two radicals, root 2 times root 6, you can make it root 12. That will work. But that is not all. Oh no, that is not all, said the cat in the hat as he jumped on the ball. Gotta get so it's like a sixth sense, right? You hopefully have a sixth sense about fractions. If your grade 7 little cousin comes over for math help this weekend and writes down an answer 5/10, and they're very proud, 5/10. You're proud too, you're like, good job, 5/10. But meanwhile, your spider sense tingles a little bit. You're like, but it's, you don't, what, as your teacher taught, you don't 5/10. That's not a thing. 1/2, please. You got to get that spider sense going for radicals too. Root 12, maybe. 4, oh, 4. You just start checking those perfect squares. Root 4, root 3. 3, root 20. What is it? 4 and 5. Need some room over here. So I get 6, 2, root 3, 3, 2, root 5, 12, root 3, and 6, root 5. And again, you can type the original one into your calculator. It'll come down to this, and you're like, oh, good, I feel good that that was the right answer. So that's like, in your homework, you can check in the back of the pages there and check the answer, and you feel good, like I got it right. But you can do it on you got the right calculator, you can do that on a test too. You can type it in and get that answer. I saw a couple of frowns there. Did I make an error there? No? Okay, who's still frowning? I'm looking, checking. Question?
So you just flip it around, wait. So you flip the 3 and the 6? I'm confused.
Here to here?
Here
to here.
No, the very bottom one.
Yes?
So, and then if you go to like the final equation,
Yeah?
like the one below that, it looks like you flipped it.
I didn't flip anything, I just multiplied 6 and 2 together.
Oh, sure.
3 and 2 together. So that's just multiplying together the numbers that could multiply together. And regular numbers can multiply together. And radicals can multiply together. Okay. But when you multiply a number with a radical, there's nothing more you can do. 3 root 2, without going to some crazy decimal. Yeah? Hazel.
How did you distribute and get like 3 and then square root of 2 twice? Like it's on both sides of the addition side.
Oh, I like this question. I'll do a little note up here for you. Say I do 5 times 2x plus 3. When I do that, 5 gets multiplied by 2x, but 5 also gets multiplied by 3. That's what distributing sort of means. So, for instance, when you guys come into class and let's say I've got your practice quiz for you, I distribute it. Everybody gets one. Here, everybody gets a 5. And here, everybody got a 3 root 2. You get to multiply by all of those. Now, where does it come from numbers-wise? And this is what I showed a couple of days ago about multiplying numbers and my crazy kids as we're waiting for the school bus. As I said, we can do questions like this, 5 times 13 in our head, by thinking of 13 as 10 plus 3. So clever. Changes your mental math game completely, where you're like, wait a minute, these people who can do mental math, maybe they're not smarter than me. Maybe they just know something about the situation. Because then the 5 gets multiplied by the 10, and the 5 gets multiplied by the 3. They each get a 5 when it's multiplying and adding. Does that answer the question? Yeah, I rewound all the way. This is why. Don't wait around till this weekend to ask me questions. I won't. I'm not going to your house. I'm here now. So when the questions come to you in class, ask them, and I'll rewind and I'll keep going until you stop frowning. Yes? So get good at the frown, and I'll just keep trying to read the situation and try to fix the problem. Although I had some mad texting last night. Again, well, maybe one person I figured out who you are. I scrolled back through and I looked at the writing and I tried to figure it out. But mad texting last night was several people. Where was I last night? Oh, I was playing catch with my son. I was playing ball. And I had my phone. I'd throw it to him. He'd throw it to me. I'd throw it to him. He'd throw it to me. I'd throw it to him. He'd miss it. It'd bounce away. Quickly text somebody. That's why the delay can be weird when I'm texting you. I might be doing something, and then I'll get to you when I can. Was there another question? I thought I saw another hand out there. We're good? Slide 3 of 7. Not too long. Hey, we might be done by 11 again. That's pretty short for us. Expand and simplify this one. Binomial multiplication. How is this one different than the previous one? It's not very different. It's pretty much the same, but what's the different stage here?
It's like you add and then times by each other.
Mm-hmm.
I have a different question kind of thing.
Okay.
This is probably not a question, but why for one of them in the brackets, why can't you do just 3 plus 4 and then 2 plus 5?
They're not like terms.
Oh, true. Wait, what do you mean?
Oh, what I mean, okay, let's rewind all the way to it.
They're both whole numbers. They're both
This is a root 2 and this is a root 5 though.
Oh.
So let me rewind for just a second, just in case other people have the same question. Because other people could have the same question, and you could just be playing along. Some of you might be playing along, you're like, this is what you do. I don't know why you do it, but this is what you do. If I go to my fridge tonight, because me and Mrs. Ta want to go for groceries, and she says, what fruit do we have? I say, we've got 5 oranges and 3 apples. I've got no way to shorten that information down. I can't say to her, we've got 8 orange apples, oranges. There's no way to combine apples and oranges. They're different types of things. I can't go 5 and 3. You go, well, they're 5 and 3 fruit. I'm like, well, she didn't ask that. She asked, what do we have for apples and oranges? So how did that play out in grade 9? 5x plus 3y, can't put them together. They're not the same stuff. 3 root 2 and 4 root 5, they're not the same stuff. When they are the same stuff, yeah, that's what I showed in the first example today that you didn't copy down. I put together the root 3s because they were all the same. They were all root 3s. This time, they're not same roots, so I can't be adding them together. So back to my question. What can I do with 2 binomials like this?
Well, you can collect like terms or whatever?
Not yet, I can't.
Oh, but no, because one's 3, 2, and then one's 4, 2.
Yeah, but they're not added.
But yeah, I know they're multiplied by each other.
Yeah?
So can't you just multiply them by each other?
We are going to try to multiply these 2 brackets together.
Oh.
But how do I do it when there's add in this brackets and also add in this brackets?
You doing the FOIL thing?
We're doing FOIL. And if that's a giant click for you, good. That's what we're trying to accomplish here. Is like, oh, when it's add in the first bracket or subtract, and add in the second bracket or subtract, that's when FOIL kicks in. And in other ones, you might have gone 3 brackets with 3 in the other brackets, and then it's the whole big thing. But here, this is just 2 and 2, so we can just do regular FOIL. So 3 root 2 times 4 root 2. Technically speaking, some people just draw the arrows and go, that's what I'm supposed to do. Technically, the way you're supposed to do this is draw the arrow and write what you found. 3 root 2 times 4 root 2. Then draw the next arrow and go plus 3 root 2 times negative 3 root 5. You're saying negative. I thought that was subtract. Is it subtract or is it negative? Yes. Yes. It's subtract if I was putting it with this one, but it's negative if I'm putting it with that one. So subtract and negative are interchangeable up to a point. Yeah? Then the other part of FOIL is 4 root 5 times 4 root 2. And then this one's 4 root 5 times negative 3 root 5. Now, I'm going to do the extra step. I'm not going to get lazy, but you can. I'm not telling you it's lazy if you, as the teacher, it would be lazy for me to skip this step and not explain it. But you might find that you can do the next step. You can skip this next step I'm going to do. So I'll do it in purple. Purple, optional step depending on where you are with this, is to write this as, oh, that's 3 times 4 times root 2 times root 2. And this one's 3 times negative 3 times root 2 times root 5. And this one's 4 times root 5 times root 2. And this one's 4 times negative 3 times root 5 times root 5. Then the numbers can multiply together and the radicals can multiply together. So I get 12 root 4 plus 9 root 10 plus 16 root 10 minus 12 root 25. There's 3 things that you could see to do now. I don't know which one you'll see. Which one do you see? Yes, what do you see?
Simplifying like I actually simplify like the tens.
Yeah, these are both root 10s. So I can put those together. There's the middle part, 25 root 10. What about this part? This negative 3 multiplied by this negative 3 to give positive 9. Did I make a mistake? Maybe I copied down wrong. Let me look. 3 root 2, 4 root 2, 3 root 2, negative 3 root 5, 4 root 5, 4 root 2, 4 root 5, negative 3 root 5. Okay, so which one are you talking about? I looked over that last. Oh yeah, that's completely wrong. Yeah, I got distracted. Good for you. Good catch. That's positive 3. It's good that you saw me do it. I didn't do it on purpose, but it's good you saw me do that. So when it happens to you and you miss a negative and you're like, oh, I missed a negative. This course is too hard for me. I shouldn't be an 11U. Like, what are you talking about? Todd did it. It's easy to drop a negative. In calculus, we have a saying, it's always a negative. And I always go back and, oh, one stupid negative messed up the whole thing. On a test, how many marks do you think I'd take off for that mistake?
0.1.
0.5, just because, I'd be like, sometimes twice you do it on a test, 2.5s, and I only take off 0.5 total because I'm like, that's just a negative. It's no problem. So then that's negative 9. Negative 9 plus 16. See, it messes up everything. It completely messes up your final answer, even though it was one silly little mistake. Thank you for that. Good question. Now, what else do you see?
I don't know if this is right, but like the 25, I feel like you could do like 4 and 5. No, that's not right. Maybe you could do like 12 and like you can split that up or something.
Well, what are the suspects we're looking for? We're looking for 4.
And a 5.
It doesn't divide by 4. 9, it doesn't divide by 9.
5.
16 doesn't divide by 16. 25. This is a perfect square. It doesn't need any tricks. Square root of 25 is 5.
That's awesome.
So easy it was hard. That happens in math too all the time. It's like, this one I didn't have to simplify the radical because root 25 is 5. And the same thing happens over here. Root 4 is 2.
Why is it in the bracket?
Because I'm multiplying.
Oh.
Still got to multiply those. So I get 24 plus 7 root 10 minus 60. And I can go one more step. 7 root 10. 7 root 10 minus 36. I just put that 24 and that 60 together. And I wrote the negative 1 second. That's not a big deal. Nobody would ever mark it wrong. It just feels easier to write if you've got a positive and negative, write the negative second. Yeah? Question?
Can't we simplify it even more though? Or like...
No, because these aren't like terms. 7 root 10 is, I've got 7 root 10s. That's apples.
No, but can't you solve it?
Like as a decimal?
No, because if you put it into your calculator,
It'll just say this. I could force my calculator to give me something better, or something different, not better. When I have 7 root 10 minus 36, when I type that into a good calculator will be like, I don't know what you want me to do here. You want to write it the other way around? I can't do anything here, but you can force it to give the decimal answer if you needed that.
yeah, like what if you just do...
So it's like, if you work at Apple, like this. If you work at Samsung, round it off, what do you care?
But what if you just do 7 and like the 10? What does that give you? Because that has to give you a number.
It does give you a number. Watch what the number is. 7 root 10. That gives you a number. 22.1359432.
No, well, just minus that by 36. Oh, that is 13.04.
Yeah, that would give you the decimal answer. Again, great if you want to work at Samsung, but I guarantee when they make this, they're not rounding off to the nearest tenth.
Oh, they're just putting...
They're keeping that because it's exact. It's perfect. It's not rounded. Yeah? I'm sort of exaggerating, but not much. There's a reason why we keep them exact. It's because they're exact. Other questions? More time? Oh, no, not purple. Okay, if you've drifted off on me on a Thursday, if you've wandered away, you're like, I really tried, Mr. Todd. I've been trying to pay attention, but I'm worn out. Well, you're going to want to come back for this. And if you're a highlighter person, maybe you go shopping this weekend, put that on your to-do list. I'm going to go get a set of those 4 highlighters. And while you're doing a lesson, highlight some stuff that you can look back on later and go, this is what he was talking about. This is what he got really wound up about. This is where he stopped for a minute and did that line where he goes, okay, now you got to pay attention. Yeah? Now's the time. This is called rationalizing the denominator. Yesterday, I said, but didn't do anything about it, I said that a radical is not in simplest form if there's a radical in the denominator. There's a million good reasons why that is. There's lots of stuff coming where any radical, here look at A, a radical in the denominator, that's bad. But at this point, you should be like, well, yeah, what am I supposed to do about it? Somebody texted me last night, said, well, how you said no radicals in the denominator. Question 7b or something like that, it's got a radical in the denominator. I said, I know, I didn't finish it. I know, it's radicals part 2. Yesterday you were stuck with it. Now I'm going to fix it, okay? The process of removing radicals from the denominator is called rationalizing the denominator. What it means is get it to a whole number. Get it to a not radical in the bottom. Rationalizing the denominator often involves multiplying both the numerator and denominator of the fraction by the same specific fraction. What? That's not going to make any sense until I actually do it. Yeah? So the example says, go ahead and rationalize the denominator. All right. This is fun. This is fun, what I'm going to say next. One of the best tricks we do in math, I call this a trick, is multiplying by 1. You've done it before. You didn't realize you were doing it. Let me go up here and do a small fraction question. And we'll talk about what you do, and then I'll try and get you to tell me why you're allowed to do it. Because if you really think about it, it's sort of like cheating. 1/2 plus 1/4. If I'm going to add 2 fractions, what do I need? A common denominator. And the common denominator here is 4. So the 1/4 is over there going, I already got that denominator. I'm ready to go. You get common denominator 4. How do I do it? What is it I do to this fraction to get denominator 4? Multiply the top and bottom by 2. Now, when you were initially taught it, your teacher probably correctly said something like, as long you can do anything you want to a fraction. As long as you do the same thing to the top and bottom, it'll stay the same, which is a little mysterious. It's like, are you sure that's what happens? I mean, I know you bought into it for years, but technically what you're doing, if you really want to understand it, is you're actually going to take this 1/2 and multiply it by 1. Do you see my active board's going a little messy there? I can't even draw a straight line on this thing anymore. I'm going to multiply 1/2, I'm going to put it on a new line, 1/2 by 1. That's what Dion said, multiply top and bottom by the same thing. Multiplying by 1 does that. Now, you see that I'm always allowed to multiply by 1. I'm not cheating. You can always multiply by 1. But just like the future school you're going to go to, or your future spouse, or who you're going to go to the prom with, you've got to choose the right one, the correct one. In this question, the one I'm going to choose is the one Dion said. He said multiply top and bottom by 2. I know you don't do that in grade 8. You don't think of it that way, but that's what you're doing. That's what makes the process work. Fast forward to grade 11. I'm going to multiply top and bottom by 1. That's what I'm going to do. Totally allowed to always multiply by 1, but I'm going to choose the right one, and it's a clever one. Because it seems impossible right now. It seems impossible that I could multiply by something on the bottom that would turn this root 2 into something that's not a radical. What radical could I multiply root 2 by to end up with something that is no longer a radical? Ooh, let me repeat the question, because it's a tough one. What radical could I multiply by on the bottom that when I multiplied it by root 2, what I got would no longer have to be a radical? Root 2. The whole time I've been talking here, root 2 was on the bench going, Coach, put me in. I can do this. It won't be hard to remember. Whatever is in the bottom of the radical, multiply by that radical, top and bottom though. You've got to do the same thing top and bottom. Over here with the fractions, I did it with 2. You don't buy it? Watch this. 3 root 2. Root 2 times root 2 is root 4. And what's the square root of 4? 2. That's some math magic. Now there's no radical in the denominator, which maybe you're still unimpressed. You're like, well, why do I care if there's a radical in the denominator? Oh, we care. If we're going to add this with other fractions, if we're going to do other things with it, we're not going to want radicals in the denominator. So from here on in, not in last night's homework, you got away with it last night. From here on in, if you end up with a radical in the denominator, just multiply top and bottom by whatever radical that is, and you'll get something that I claim is better. And you cannot believe it at some point. It doesn't look necessarily better, but it doesn't have a radical in the denominator. Whew! Long way to go here. Need someone brave to answer this question, because then I'm going to say they're wrong when they're actually right, okay? Just for the drama of it. Just for a little fun on a Friday. Oh, it's technically Thursday, but it's your Friday, isn't it? Yeah. What should I multiply this by to get the radical out of the denominator? Remember, get ready. I'm going to tell you you're wrong when you're actually right if you say the right thing, because I want to say something funny. What should I multiply? No trick, except you know it's a trick. Then I'm going to say you're wrong. Go ahead. What should I multiply top and bottom by?
Root 5.
He says multiply top and bottom by root 5. I say no. What you're multiplying by is 1. That's what we're up to. If I was only teaching this concept, I would say root 5 or root 5. I would. But I'm trying to teach something bigger here that we're going to use in other situations. Multiplying by 1 is a smooth. It might be the best mathematical move I know of in all of math, is to multiply things by 1. But he's actually correct. I acted like he wasn't, but he was correct. Multiply top and bottom by root 5. Root 5 will take care of root 5. That will work. And so the top becomes root 5. The bottom becomes root 25. And I can't wait for tonight or tomorrow when someone texts me and says, Ms. Todd, it doesn't work. You said if I multiply top and bottom by the radical that I see there, it'll get rid of the radical. I did it. It didn't work. The radical's not gone. And all I'll send back is a little smiley face. And then I'll wait. I'll be watching my phone waiting for you to go, ah! What is the square root of 25?
5.
5. It works. Root 5 times root 5 is 5, and I end up with something with no radical in the bottom, which I'm claiming is way better. Okay? Whew! It's good stuff. That's some good mathematics there, let me tell you. Wait till you see what we can do with this multiply by 1 stuff later. There's some algebraic stuff where we're going to need that. But do you have any questions there? You might not. After seeing the whole thing, you might be like, oh, okay, well, I can do that. Multiply top and bottom by whatever radical I see. Conjugates. Conjugates. The binomials 7 plus 2 root 3 and 7 minus 2 root 3 are called conjugates of each other. They're the exact same, except the middle sign has changed. That's what a conjugate is. Two terms, two binomials that are exactly the same, but the sign in the middle has changed. And it says something interesting happens when conjugates are multiplied. Maybe you'll find it interesting, maybe you won't. Now it's two brackets multiplied together. One's got add, one got subtract. This is a FOIL situation. So I'm going to FOIL this out, and apparently something interesting is going to happen. Okay? Root 7 times root 7. Root 7 times negative. Root 7 times negative 2 root 3. Plus 2 root 3 times root 7. And then 2 root 3 times negative 2 root 3. And again, you might be, by the time you do a few of these, you might find some shortcuts. Root 7 times root 7. I'll do the extra step, but I'm hoping some of you are like, I know what root 7 times root 7 is. I don't need your extra step to know what that is. But anyways, root 49. And then this is negative 2 root 21. And this is positive 2 root 21. Huh. Interesting. And then this is negative 4 root 9. Two lines of interesting stuff. First, negative 2 root 21, positive 2 root 21. Those cancel. So I'll get out my fancy cancel pen. I'm going to use green. Whoop, whoop. So that's one interesting thing, and that would be pretty cool when multiplying conjugates by itself, but I'm not done. Root 49. 7. Root 9. 3. No more radicals? I've de-radicalized it. Conjugates de-radicalize things. You don't care. All right, well, wait till you see on the next slide. Here's the important sentence. The product of conjugates is always an integer with no radical. Actually, it could be a real number. It could be decimals, actually. But for the sake of my example, I'm just going to say integer. But no radicals. No radicals if you use the conjugate. I'll say that again to get ready for the last slide. And I'll say it loud into my microphone. Multiply by the conjugate. End up with no radicals. Okay. One slide to go. Questions about any of these steps, though? My brain is mush, Mr. Todd. It's been a long 2 weeks. I know. Friday, Saturday, Sunday, eat good. Mommy will love you up and make you dinner and do your laundry and pat you on the head. Get some homework done. And come back Monday and we'll go again. No, we don't, do we? Monday's review day. Oh, yeah. Do some review this weekend. Work period Monday. By Monday night, maybe you'll start to believe it can all work out again. Yes.
Is that like similar to the actual test?
Yes.
Okay.
Not similar like, oh, these are the exact same questions. Similar like,
Well, some
if you
teachers
did
like
this, you should be ready for that.
Some teachers like to like trick you and like put questions that are gonna be on the test, not on that, and do the complete opposite. My old math teacher liked to do that a lot.
Let me answer that in two ways. One is, if you haven't done all the homework and you just do the review, it's going to feel like the teacher's trying to fool you. Because yeah, I'm not just going to select from the review. I'll select random questions like the area question from the homework. You're like, what is this? Well, if you did the homework, you'd know. It's just area, length times width. You know, that wasn't a huge problem. You know. Secondly, I will change the questions, and that may make you feel like it's completely different. But that's just like different numbers work out differently sometimes. Okay. I don't know what other teachers are doing, but I'm telling you that when I make the test, I look at the review and go, okay, most of this should be covered here, and then a couple of random homework questions from the chapter, just to keep you on your toes and keep you doing your homework. Or what's the point of the homework? Then you get to university, and they don't follow those rules at all. They do whatever they feel like. All right? So just be happy you're here with me now. Go back, she says. How am I doing on time? Way over. I thought it was going to be done by 11. I'm always wrong. No, I did some extra explaining, though, didn't I? I did some distribution stuff. Yeah. Which I'll always do. Incidentally, I'm going to rest up on the weekend, too. If you saw me and Mrs. Todd walking around on Friday, we both teach our brains out. Who's got Mrs. Todd this semester? We teach our brains out. Yeah? So we look the same as you. We just have to pretend we're not. I'm up here going, woohoo! Watch in 10 minutes what happens. Look over to me in the comfy chair. You'll be like, oh, he's as tired as we are. Maybe this is about toughness, not about not feeling tired. More questions? More time? No, she says. Simplify 5 over 2 root 6 minus root 3 by rationalizing the denominator. Okay, purple. Over here is in purple. You can write it down if you want. Maybe at the end you're like, I'm writing that down. Or maybe at the end you're like, I don't need that. Okay? Mr. Todd say, when I get radicals in the denominator, multiply by whatever radical you see. This question says root 6, root 3. You're like, so which one do I multiply by? Both, you say. Okay, so I multiply by both root 6 and root 3. This is my first attempt at this that will not work. On the top, I get 5 root 6 root 3. On the bottom, I get 2 root 6. I get 12 root 3 minus 3 root 6. Mr. Todd, wrong. It don't work. You're right, it doesn't work. If there's multiple radicals there, added or subtracted together, the trick I've shown you so far doesn't work. Multiplying two things that are added or subtracted by one single radical, no matter what you use, you go ahead, take it as a challenge and go and see if you can figure one single radical that can get rid of these two radicals. You won't be able to find it. If only there was something we could multiply two things added, subtracted together that did get rid of the radicals. If two terms are added together and they've got radicals in them, what could you multiply by that de-radicalizes them? That's the wrong words. I like that word, de-radicalize, but gets rid of the radical part. Does anybody know what you could multiply by that gets rid of the radical part?
1, 2.
Oh, the conjugate.
The conjugate.
Yeah.
Now this time the conjugate's on the bench. You know, last time I put in the radical. This time the conjugate's in the venture column. No, no, this one's mine. Out of the way. I got this. I'll de-radicalize this thing for you by multiplying by the conjugate. This is whacked. Here it comes. 5 over 2 root 6 minus root 3. I'm going to multiply it by 1. Oh, not in purple. These aren't optional steps. Switch back to black. 5 over 2 root 6 minus root 3. I'm going to multiply that by 1. Beautiful trick. I'm totally allowed to, excuse me. I'm always allowed to multiply by 1. That won't change the value, but I got to choose the right one. Here's the right one. The conjugate. What's the conjugate of this disaster that's in the bottom here?
Is it 2 square 6 plus square 3?
Yeah, 2 root 6 plus root 3. Awfully tempting at that point to go, are you kidding me? And the answer is no, not kidding you. Here we go. Multiply the 5 by the other numerator. I get 10 root 6 plus 5 root 3. There's radicals in the numerator. Don't care. I want no radicals in the denominator. 2 root 6 times 2 root 6 is 4 root 36. I'm just... Messages come out with that. I'm always scared, right? Maybe you don't have an old computer. This thing's old. That was where I was going to press that, and the whole thing was going to shut down. That was going to be the end. Then you would have seen it. I would have grabbed this thing. I would kick that computer off the edge and go. I don't know what happened, Mr. Duff. Computer stopped working. I did do a shortcut there. You can get there. You can get there. Come on, do some homework. You'll get there. Where 2 root 6 times 2 root 6, 4 root 36. Yeah? 2 root 6 times 3 root 3, 2 root 18. At that point of this procedure, you lose faith in Mr. Todd. In fact, you might even say my name with your favorite swear word in front of it, like, it doesn't work. I don't know what he's talking about. Conjugates don't work. You text a picture to me and you're like, look, it's not working. I'm like, you get a smiley face back going, keep going. So I do the other part of the FOIL. Negative root 3 times 2 root 6 is negative 2 root 18.
Oh, cancel each other out.
Cancel.
Cancel.
Last one, negative root 3 times negative root 3 is negative root 9. Then you text me like, well, okay, those cancel, but I still got a root 36 down there. I still end up with a radical. What's the square root of 36? 6. Well, what about this one? Root 9.
3.
3. So conjugates, magical stuff. Magical stuff. Great fun. I'm not doing any of the homework, Mr. Todd, but I'm doing the conjugate homework. It's too much fun. Mr. Todd, you and I have a different version of fun, I think. 24 minus 3, 10 root 6 plus 5 root 3 over 21. I did that pretty fast. I better check it. 2 root 18, negative 2 root 10. Yeah, 4 root 36. Root 6, 36 is 6. 4 times 6, 24. Yeah, root 24. Yeah, looks good. Are you serious? Yes. This is the way. This is the way. Nothing? This is the way? Not one person here watches Mandalorian? That's it.
Mandalorian.
Did you say, what's the Mandalorian?
Yeah.
Get your stuff and get out of here. No, I'm just kidding. Best show.
Oh. I know. Sorry.
What's a stroke feel like? Star Trek. Star Wars.
Yeah, but they're like the same thing, just different. No.
No wonder your generation gets yourself in trouble with us. Oh, that's the same thing. Star Wars, Star Trek.